Okay, recording.
Greetings, Mr. Karil. My name is Nishan, and I'm from Group 7. And these are my group members, Austin, Hemraj, and Sayanda Chua. Please move on to the next slide, please. Thank you. And this is our network topology overview. This is our design so far. And I would like to give the next slide to Sayanda Chua.
Thank you, Nishan, for presenting your part. So let's move on to the addressing plan of IPv4 and IPv6 of our network. So basically, this is the IP addressing plan. So this table outlines our IP addressing plan, which is categorized by network area. It basically maps specific IPv4 and IPv6 allocations to team members based on their birth dates to ensure unique distribution across the network. So for example, as we have here, the ping network area. So let's say we can see here Nishan's birthday is 30 March 2005. So basically the IPv4 which is used is based on his birthday, which is 202 202.30.3.0/24. So another example would be the blue network area. So one of our team members, Hemraj, his birthday is 31st August 2005. So his IPv6 address, which is used, is 2001 colon DB8 colon 3108 colon 2005 colon 0/64. Moving on to the purple network area, we have Austin's birth date and the web server follows his birth date, which is 202.14.10.1/24. The rest of the servers such as DNS servers, email servers, and also FTP servers follows my birth date, Sayendra Chua. So last but not least, we have the radius network area. So basically, we randomly assign a random birthday because there are no members handling that network area. And the IP4 address follows the random member's birthday. So that's all from me.
Moving on to routing configuration. So this is RPNG. We have I normally use it for the light blue zone and purple zone. This part. Next slide, please. And this is RIP version 2. So this part we use it for the pink and purple part, just for IPv4. The previous one is for the IPv6. And these are the command in order to activate the version 2 of this routing. And these two RIPs just to make things faster. Moving on to next slide, please.
All right, thank you for your presentation, Mr. Nishan. I will carry on from here. So for this web server configuration, as you know, all the topologies in the purple zone is already like dual stack, means it uses the IPv4 and also IPv6. And now over here in the web server, we go to the index.html, and then we can, let's say, like edit a sentence or something. And once we edit the sentence, there's nothing much to do on this web server itself. So, but you just need to make sure you need to activate both the HTTP and HTTPS. Next slide, please. Now, for the DHCP server, especially in the green zone, and also next slide, is it about the pink zone as well? Next slide. Can I see the next slide? Next slide. Okay, previous. Okay. So I will talk about the main configuration we did. This is like one of the examples from the green zone, for example, where we did the DHCP server. Over here, we added the default gateway from the router that is connected to this server as a default gateway and use the DNS server that we get from the one in the purple zone. Once we do that, we set up the start IP address, save all our changes, then we go to the desktop, we set up for the server's own IP address, static of course, and also its own default gateway. Once we all set up this, it should be like when we activate in the PCs, it should be working actually. Um, and next slide, please. Okay, now for this DHCP v6. This is one of the crucial parts as well. As you can see over here, in order to configure this DHCP v6 blue zone, we have to do several configurations in the router itself. We need to enable the unicast routing, and after that we need to like enable the IPv6, assign the IPv6, then activate the auto config mode, and then only we can adjust the creating pool part and also adding the prefix part. And we can also optionally add the DNS server, of course, obtained from the purple zone itself. Once this setup is completed, all the PCs that is connected in the light blue zone will have an automatic IPv6 network. Next slide, please. Now this configuration is for FTP. Okay, now for the FTP part, it's basically like allows the user when they when they use the FTP on the other side in any of the PCs, they can actually insert the username and the password. They can actually like write to the files, read files, they upload files and all so many operations. But in this basic setup, we will just focus on the login test later on, of course. Next slide, please. Next slide. Oh. Okay, now email server. For email server, what we do here is we just activate the SMT service. It is for sending requests, and POP3 services is to receive requests. Once we done this, we can actually set up all on the user and the password, and it should work as intended lah. Next slide, please. DNS server. Over here in this DNS server, we can actually in this DNS server, we are connecting the FTP server, web server, and also the email server over here. A record refers to the IPv4 configurations, and 4A record refers to the IPv6 records. The purpose of doing all these records is that so we can access the DNS server later on in the PCs from the light blue zone or the pink zone. Next slide, please. Okay, I will pass it to Mr. Austin.
Okay, thank you, Mr. Ramirez, to present it. Okay, moving on to our wireless infrastructure, we have implemented a secure wireless setup across two primary zones, which is the pink wireless and the green wireless areas. The objective here was to ensure that different departments, like specifically like the marketing, engineering, and gas, have the thorough access points within the network. Okay, so this one is our wireless security is radio servers. During our configuration, we define that the specific client's profile and share secret that match the setting on our wireless controllers and access points. Then you can see we got the marketings and the engineering guys, the handling the client name there, and then got the user and the password also there. Okay, and then this server act as the central gatekeeper. Then when a user attempts to connect to the marketing or engineering wireless network, the access point forward those credentials to this Radius server for verification. This cell not only exchange security, but also provide a scalable way to manage user access across the dual stack IPv4 and the IPv6 environments. Okay, go to the testing result. This DHCP v6 Blue Zone is the ping for the PC to the web server. During this, we using the PC from the Blue Zone, PC from Blue Zone to the server that to FTP server located in the purple zone, providing that our routing configuration, which is IPing and IPing to V2 are functioning correctly across different network segments. Okay, this is the email testing. And this we perform the email testing to ensure the mail server is reachable and functional. Additionally, we conducted the FTP login test, FTP login test specifically for IPv6 and wireless using a user to confirm that data transfer service are accessible regardless of the connection method. Then finally this one, we tested the web browser access while the web server and DNS. This was confirmed for both IPv4, which is in the pink zone, and the IPv6 in the blue zone, as well as for our wireless clients. Then this one, connectivity metrics, we confirm successful pings and data flow within the green and pink zones, and more importantly, across zone. We also do that, such as the pink to green and green to purple, demonstrating a fully integrated and routable network. Okay, this for our presentation. Thanks for listening.
The end.
Thank you.
Okay, so for the simple simulation process, I will demonstrate how the packet flow works from the PC1 and let's say to the web server. And we hit the play button. As you can see here, it works, but if it reaches the switch or anything, and it reaches the blocking state, it might be blocked if it goes through the blocking path, of course. So it's working. And it's successfully sent. That's all for now. The connection works. I hope it's enjoy it. Thank you.